7 Possibilities Before the Big Bang. Hello everyone and welcome to my channel. Have you ever wondered what kind of cosmic theater played out before that magnificent Big Bang? In this article, we will take you through the mists of time and space to reveal 7 mind-blowing possibilities. Perhaps the universe never had a true beginning, but rather an endless, cyclical, and marvelous cycle. Perhaps it all began with the mysterious ebb and flow of the microscopic world. Perhaps a sudden switch was flipped on the entire existence, or perhaps the whole of existence was suddenly destroyed by the Big Bang. Or it could be that the whole of existence was suddenly switched on, or, even more breathtakingly, a multiverse is envisioned, suggesting that we are just one of countless parallel worlds. Each of these possibilities is like a magic door to the unknown, waiting for you to push it open. You know, the first impression of the Big Bang Theory is always that of a shocking beginning 13.8 billion years ago. The entire universe appeared to be born from an extremely hot and dense singularity. But here's the problem. If the Big Bang represents the beginning of the universe, how do we define what we call before? After all, at the time of the Big Bang, time and space were in a state that we can hardly imagine, and some scientists even believe that there was no time in the traditional sense. As the famous physicist Stephen Hawking once mentioned, time began at the moment of the Big Bang, and we can't describe what happened before the Big Bang in terms of the usual cause and effect relationships. In other words, asking what happened before the Big Bang may be like asking what happened before human beings were born. There is no such thing as before. There is no such thing as before. This idea is partly derived from Einstein's theory of general relativity, which tells us that time and space are intertwined, and without the birth of the universe, the concept of time would seem to be meaningless. But this does not mean that we stop pursuing this. On the contrary, since the second half of the 20th century, physicists have been trying to break through this limitation, trying to use quantum theory to unveil the mystery hidden before the Big Bang. The no-boundary condition. The universe has no boundaries and no before. In the 1980s, James Hartle and Stephen Hawking collaborated to put forward the theory of no-boundary conditions. The core idea of this theory is eye-opening. Perhaps the universe doesn't have a definite beginning at all, just as the surface of the Earth has no boundaries. Imagine if you started on Earth and kept walking, you'd always come back to the same place, right? In this way of thinking, the Big Bang is just a turning point in the history of the universe, rather than an absolute beginning. Hartle and Hawking's theory, they use a similar circle rather than straight line way to describe time. In other words, the universe can be viewed mathematically as an infinite circular space-time structure with no sharp beginning or end, so that before the Big Bang is no longer a meaningful question. As Stephen Hawking wryly put it in one of his lectures, if you try to rewind a videotape of the universe, you'll find that at the end of the rewind, there isn't a single frame that's before it. While this idea may sound a bit abstract, it offers us a whole new path to think about, and one can't help but imagine that perhaps our universe is like a never-ending circle, always looping back and forth with no real beginning or end. The nothingness hypothesis. Have you ever thought that before the Big Bang, even basic concepts like time and space did not exist? This is the core idea of the nothingness hypothesis. Before the Big Bang, there was nothing, absolute nothingness. In other words, we often say that the universe did not burst out of an empty space, but suddenly jumped from a state where nothing existed to a state where something existed, from nothing to something. It is a sudden change from nothing to something, from nothing to something. Simply put, the nothingness hypothesis holds that even space-time itself, the basic stage of everything, did not exist before the Big Bang. Imagine trying to rewind a movie and rewinding to the very beginning when there was not even a background on the screen, absolute nothingness. In this view, the word before also loses its meaning because time was born at the moment of the Big Bang. This view emphasizes that the Big Bang was not an explosion ignited in a pre-existing space, but rather a sudden switch in the whole of existence was flipped. It was like a bolt of lightning in the darkness that suddenly lit up the night sky, and everything was born. Here, nothing is not simply equated with emptiness or zero, but is a kind of absolute non-existence, without any law, without any substance, and even without any concept. There is no law, no substance, not even a concept. Suddenly, there is something: time, space, matter, energy, and the fundamental laws that make up everything in our universe, all at once. Yes, this concept sounds incredible, but it's also one of the most exciting discussions in modern physics and philosophy. Many scientists and philosophers, such as Stephen Hawking and a number of other theoretical physicists, have explored this issue. Hawking has said that time began at the moment of the Big Bang, so asking, what was before the Big Bang, is really like asking, what was Mom like before she was born? The question itself is lost. The question itself is meaningless. Why would anyone support this view? 1. The origin of time. If time began at the moment of the Big Bang, then there was no concept of time before the Big Bang, and naturally there is no such thing as before. 2. The scope of application of the laws of physics. Existing physical theories, such as the general theory of relativity, in the extreme high-temperature and high-density state, such as the Big Bang singularity, has lost the ability to describe. Perhaps in that extreme state, the traditional sense of existence no longer exists. 3. Philosophical reflection. Philosophically speaking, nothing, as an absolute concept, is the antithesis of all existence. If everything emerges from nothing, then this sudden something is also full of mystery and philosophical significance. Cyclic cosmology. The Big Bang is just an oscillation in the cycle. Speaking of which, have to mention another very attractive theory, cyclic cosmology. It suggests that the Big Bang was not a single creation event, but a cyclical process that repeats itself over and over again. In this theory, the universe undergoes a series of expansions, contractions, and re-expansions, and each Big Bang is just a rebound from the previous round of cosmic collapse. This idea can be traced back to ancient Indian philosophy, but in modern physics, there are many scientists who have tried to describe this cyclical process using mathematical and physical models. For example, physicists such as Paul Steinhardt and Nicholas Tulloch have proposed similar models, suggesting that factors such as gravity and dark energy in the universe cause the universe to undergo cycles of expansion and contraction. Imagine that each time the universe contracts to a certain point, a rebound is triggered by a limit state of density and energy, thus starting a new Big Bang. This cyclic process not only gives us a possible explanation for the pre-Big Bang state, but also provides us with a larger perspective on time and history. Interestingly, in the 1990s, with advances in observational technology, scientists discovered that the expansion of the universe was actually accelerating, which brought the mysterious character of dark energy onto the stage of history. Some have speculated that this accelerated expansion could signal a future tearing apart of the universe, or a collapse after reaching a certain limit, as predicted by the theory of cycles. Although all this is still in the theoretical stage, the cyclic universe theory certainly provides another possibility for the mystery of before the Big Bang. Perhaps the Big Bang was just a moment in the process of countless self-renewal of the universe, and before that, there were countless cycles similar to the Big Bang that have been continuously staged. Quantum cosmology, the strange origins of the microscopic world. When we try to explore what happened before the Big Bang, we often have to enter the realm of the quantum world. Whereas traditional classical physical theories appear to be overwhelmed by extreme conditions, quantum mechanics reveals to us a microscopic world full of uncertainties and probabilities. It is the combination of these two that quantum cosmology seeks to explore the behavior of the universe under extreme conditions. Within this theoretical framework, there is the idea that the universe may have originated as a quantum upswing. Simply put, like the ripples we stumble upon in calm water, some tiny quantum fluctuation may have triggered a self-reinforcing process that eventually evolved into what we know as the Big Bang. Physicist Alex Veen has described the scenario. Imagine a tiny ripple popping up in an endless void, which then grows larger and larger until it becomes an entire ocean. This theory gives us a whole new perspective on the idea that the Big Bang did not come out of nowhere, but was the result of the accumulation of countless tiny fluctuations in the quantum world. However, quantum cosmology also faces a number of challenges, the biggest of which is how to unify the two pillars of quantum mechanics and general relativity. After all, under conditions as extreme as the Big Bang, the curvature of spacetime becomes so extraordinarily drastic that classical physics no longer seems able to provide a reliable description. For this reason, many physicists have worked to find a theory of quantum gravity, which has become one of the most challenging problems in modern physics. As the famous physicist Carlo Rovelli said, if we want to truly understand the origin of the universe, we must break with the traditional concept of space and time and face the microscopic world of uncertainty. String and membrane theories, strange omens in a multidimensional world. In addition to quantum cosmology, another fascinating line of thought comes from string theory and membrane theory. String theory proposes that the most fundamental building blocks of the universe are not point particles, but extremely small, vibrating strings. In this theory, all elementary particles are represented by strings in different states of vibration. What's more, string theory predicts that the universe may have 4 more dimensions than we routinely perceive, i.e., 3 dimensions of space plus 1 dimension of time, and that these extra dimensions may somehow be curled up and hidden in scales that we cannot directly observe. Membrane theory extends this idea further by proposing that the universe may be one of a series of higher dimensional membranes. According to this scenario, different universes could exist on different membranes that interact with each other through some unknown mechanism. It has been speculated that our Big Bang may have been due to a burst of energy triggered by the collision of 2 higher-dimensional membranes. Imagine 2 giant invisible balloons colliding with each other in the dark, instantly releasing a staggering amount of energy. This may have been the prelude to the Big Bang. Many string theory scholars are enthusiastic about this, believing that this theory not only explains the origin of the Big Bang, but may also reveal to us the deeper structure hidden before the Big Bang. As renowned string theory physicist Edward Witten once quipped, our universe may be just one note in a multiverse score that is far more complex than we think. While these ideas may sound implausible, they provide us with endless possibilities and new theoretical tools for those trying to answer the question of what really happened before the Big Bang. Talking about this, you may realize that our discussion of what really happened before the Big Bang actually involves a lot of mysteries that have yet to be solved. In fact, it is this very unknown and uncertainty that constitutes the most fascinating and intriguing aspect of science. Every time we think we are close to the truth, new questions creep up, forcing us to constantly come up with new hypotheses and theories. Scientists have left behind many interesting stories in the process of exploring this question. For example, in the late 1960s, when the physics community was still arguing over the Big Bang model and the steady-state universe theory, a young physicist suddenly had a flash of insight during a late-night walk and put forward the idea that the universe originated from quantum fluctuations. He went back to his lab and wrote this idea down on a piece of draft paper. Although no one really understood his idea at that time, a few years later, this idea gradually took its place in quantum cosmology. Stories like this not only make people marvel at the serendipity and creativity of science, but also make us realize that behind every great theory, there may be hidden countless nights of solitude and contemplation. Because of this, we always hear the old saying when we explore the pre-Big Bang question, science is always progressing, the truth is always getting closer to us, yet it is always daunting to us. This is not only a reverence for the unknown, but also an affirmation of human ingenuity. As Nobel Prize winner Richard Feynman said, I like to ask, why? Because that's the doorway to a bigger world. And every time we ask questions about the pre-Big Bang era, we are using the key of why to try to open the door to the ultimate mystery. In addition to the theories mentioned above, there is another controversial but very attractive conception, the multiverse theory. According to this theory, the universe we live in may be just one of countless parallel universes, each with its own unique physical laws and origins. In other words, there may not have been a single beginning before the Big Bang, but rather an infinite number of universes that were conceived and coexisted at the same time in some kind of transcendent context. This idea was first put forward by physicist André Linde, who pointed out that quantum fluctuations could, under certain extreme conditions, create an infinite number of bubble universes, of which we are just one lucky product. Imagine a giant jello with a million little bubbles, each one a world unto itself, and the universe we live in just the brightest of them all. This scenario not only broadens our imagination, but also provides a new perspective on the pre-Big Bang state of affairs. Perhaps the so-called before does not exist in our traditional understanding of the timeline, but rather is scattered across an endless number of parallel worlds, each with its own beginning and end. In this theory, some physicists have even suggested that when these parallel universes collide or interact with each other, they may trigger an energy release event similar to our Big Bang, leaving a trace in a new universe. Although this idea is still in the stage of heated debate and mathematical modeling, it certainly adds an infinite number of possible answers to the question of what really happened before the Big Bang. As we talked, I couldn't help but sigh. Our quest for what happened before the Big Bang actually goes far beyond the scope of pure physics and even touches the core of philosophy. After all, the discussion of origin, existence, and ultimate truth will inevitably lead to a series of philosophical questions. As the ancient Greek philosopher Heraclitus said, everything changes, and it seems that everything is the result of change. So is there anything that is eternal and unchanging? When we talk about nothing before the Big Bang, does it mean that at that moment all cause and effect relationships were broken and all time and space became meaningless? This is reminiscent of some philosophical ideas from the ancient East, such as the Taoist concept of doing nothing, which in fact implies a kind of ultimate reflection on the state of nature. As Lao Tzu wrote in the Tao Te Ching, the Tao gives birth to one, the Tao gives birth to two, the Tao gives birth to two, the Tao gives birth to two, the Tao gives birth to three, and the Tao gives birth to all things. Here, the Tao is regarded as the root of all existence, which itself transcends concrete space-time and causality. Perhaps we can understand the state before the Big Bang as an existence similar to the Tao, neither tangible nor intangible, but a primordial state that transcends all our concepts and languages. Although this kind of thinking is not easy to prove with experiments and mathematics, it provides us with an important lesson. Sometimes the limitations of science lie not only in our technology and observation means, but also in the limitations of our way of thinking. Having said that, you may be wondering, how exactly do scientists approach this question step by step? In fact, the process of exploring what happened before the Big Bang is full of countless twists and surprises. Take the discovery of microwave background radiation in the 1960s, for example, when two engineers, Penzias and Wilson, were trying to troubleshoot their instruments and accidentally discovered a weak radiation signal evenly distributed throughout the sky. At that time, no one could have imagined that it was the afterglow of the Big Bang. This incident not only confirmed the correctness of the Big Bang theory, but also made scientists realize that the early state of the universe may be more complex and mysterious than they thought. Since then, with the introduction of advanced equipment such as the Hubble telescope and the Chandra X-ray Observatory, scientists have begun to make fine observations of distant galaxies and the early universe in an attempt to find traces of what might have been left before the Big Bang. Every piece of data and every observation is like a piece of the puzzle, helping us slowly put together this seemingly chaotic picture of the past life. Of course, in this process, there is no lack of failure and doubt. Many theoretical models in the derivation of the process of all sorts of incongruities, forcing scientists to repeatedly modify the assumptions. As physicist Richard Feynman once said, science is not a straight road, but a journey full of twists and turns and unknowns. This relentless pursuit of the unknown is what drives us to keep pushing our limits. Interestingly, it is in this process of intertwining experiments and theories that some of the original seemingly pie-in-the-sky visions have been somehow verified in later observations. For example, some models of quantum fluctuations triggering the Big Bang have shown striking similarities in numerical simulations. And some predictions of cyclic cosmology are in striking agreement with some of the cosmic microwave background data. While none of these pieces of evidence are sufficient for us to say what really happened before the Big Bang, they certainly provide a solid foundation for our conjectures. Did you know that over the years, many famous scientists and thinkers have expressed their own insights into the pre-Big Bang state? For example, physicist John Wheeler proposed the concept of quantum foam, which suggests that on the Planck scale, space-time is not smooth, but full of ever-turning, foam-like quantum perturbations. This view paints a picture of a microscopic space-time full of dynamic changes. On that extremely small scale, time and space itself are constantly fluctuating, as if everything is born in an instant and fades away in an instant. And then there's another big name, Alan Goose's surge theory. Although the surge theory is mainly used to explain the rapid expansion of the universe after the Big Bang, Goose himself has also expressed a rather philosophical view of the pre-Big Bang state. He argued, the universe we see is only an appearance. The deeper layer of reality hidden behind it is far more exotic than we can imagine. This poetic expression not only reminds people of those ancient mythological legends of creation, but also adds a touch of mystery to modern science. Another anecdote is worth mentioning. It is said that at an academic symposium in the 1970s, a young theoretical physicist suddenly asked, if there was nothing before the Big Bang, then what is the meaning of the word before? The question left the senior scholars in the audience speechless, and the scholar's name later became a legend in that discussion topic. Although this incident was later rumored to be an anecdote, it is a true reflection of the scientists' confusion and bewilderment in the face of such an ultimate question, but also demonstrates their courage not to be afraid to pursue the question. In fact, the discussion of what really happened before the Big Bang is not confined to the laboratories of physics. Artists, writers, and philosophers have long been filled with endless reveries about this question. They have used poetic language, abstract paintings, and even music to express their thoughts on that ultimate origin. It has been said that the universe is like a grand symphony, where every note is a marvelous collision of time and space, and the silence before the Big Bang is the deepest prelude. As the poet John Keats described it, if you gaze into the abyss will gaze into you. This quote not only evokes the impermanence of existence, but also hints at that deep unknown that lies before the Big Bang. In modern science fiction, we can also see many bold visions of the state before the Big Bang. A famous science fiction writer has conceived such a plot. One day in the future, mankind has mastered a transcendent technology, can back to the moment before the Big Bang to see a completely different from our reality. Multi-dimensional interlaced world. Although this vision can only exist in science fiction, but it certainly provides us with unlimited imagination, but also inspired many scientists to think whether one day we really can somehow see that beyond the original state of time. Nowadays, our understanding of the origin of the universe is also deepening with the continuous progress of observation technology and theoretical models. The James Webb Space Telescope, advanced particle gas pedals, and a new generation of gravitational wave detectors are all helping us move closer to those seemingly insurmountable boundaries. In the future, perhaps we will discover more clues about the pre-Big Bang state, and perhaps someday we will be able to directly capture the traces of quantum ups and downs, black hole singularities, or high-dimensional membrane collisions through more sophisticated observations. Of course, this road of exploration will never be smooth. Every new theory proposed and every new technology applied is accompanied by countless debates and challenges. Scientists need to constantly overthrow old ideas and verify new assumptions, and behind this is often a period of sleepless nights, failures, and re-energizing the arduous process. As Feynman once said, the joy of science is to keep discovering things you didn't know before, not to sit comfortably in your comfort zone and repeat old knowledge. It could be argued that the question of what really happened before the Big Bang is as much a scientific as a philosophical proposition. It reminds us that the mysteries of the universe are far beyond our imagination, and our quest for truth will never end. Every theoretical breakthrough and every successful experiment is a clear proof of mankind's courageous exploration of the unknown. As the old proverb says, on the road to truth, there is no end, only a continuous departure. Back to the original question, what happened before the Big Bang? Perhaps we could not give a perfect, unified answer for the time being, but it is this kind of unanswered question that has inspired generations of scientists, philosophers, and artists to keep asking questions and exploring. Whether it is the theory of no boundary conditions, the conception of cyclic universe, the possibility of quantum rise and fall, or the fantasy of those countless parallel worlds in the multiverse, all of them have sketched out a picture scroll full of poetry and philosophy for us. In this picture, the world before the Big Bang may not exist in the traditional sense of before, or it may be a marvelous state full of infinite possibilities and countless loops. Perhaps that is just a limitation of our understanding of time and space, and at a deeper level, everything transcends our language and concepts. As a wise man said, we can never exhaust the secrets of the universe, but it is this endless questioning that fills our souls with light. Well, that's it for this installment. Feel free to like and comment. Thanks for watching.